Good morning, everybody. Thanks for joining us. My name is Brant Kasbohm, and beginning here in a minute or two, we're going to talk about air quality and answer some questions and offer some solutions for what's become a main topic of conversation here in recent months with COVID. We're recording this webinar this morning, so if you're not able to watch the entire webinar, there will be a replay link emailed out to you, and we will also archive this on YouTube and on our workaci.com website for future viewing. And I'll be answering questions at the end of the presentation. Please input any of those on the right-hand side of the screen in the chat function, and I'll get to those after the presentation. Also, and last, before I start, we're looking for suggestions and ideas for future webinars. So please reach out to us either in the chat box, or you can email us at marketing@workaci.com for suggestions on what you'd like to see us talk about going forward. So with that, we're going to start. Thanks again for everyone for joining us today as we talk about air quality and answer some questions and offer some solutions. It's been a major topic of conversation for the past year now that we've been experiencing COVID throughout the US and throughout the entire world. So what is air quality? What are we talking about? The US EPA defines it as the quality within and around buildings and structures, especially as it relates to health and comfort of the building's occupants. Understanding and controlling common pollutants indoors can reduce the risk of some serious health concerns. So why is measuring and controlling air quality, indoor air quality, or IAQ for short, why is that important? Essentially, why are we here today? In addition to the occupant safety and health and comfort that we mentioned just a second ago in the EPA's quote, there's a few other things that are important factors in controlling indoor air quality. And the first one I'll talk about is what I'm calling occupant confidence. As we look around, there's a lot of commercial buildings that are vacant or at a very, very low occupancy rate. Schools, shopping centers, these buildings are vacant or nearly vacant. So going forward, and as we move past COVID, hopefully, how do we instill confidence in people to re-enter these buildings, reoccupy these buildings? Controlling and monitoring indoor air quality is or can be a major factor in people being confident to go back to an office or to a shopping center or to a movie theater or schools reopening. So we'll talk about that a little bit. And another major reason for measuring and controlling IAQ is regulatory compliance. We've seen that a number of states have codes and regulations in place for CO2 monitoring. A recent bill just passed in California that will go into effect later this year. And it wouldn't surprise us or wouldn't surprise anybody else for that matter if VOCs or other air quality metrics become part of local building codes or even statewide or nationwide regulations. So it's important to be proactive in these matters, to be ahead of the curve, if you will, when or if regulations require indoor air quality control or measuring, or measurement, I should say. So what's in your air? Let's take a quick step back to junior high science class and talk about what you're going to find in your air. You're going to see typical common non-toxic and inert gases, critical ones like oxygen and CO2, as well as others like nitrogen. You also have particulate matter that forms a portion of our air that includes things, combustion from coal and gas power plants, vehicle exhaust, wildfires that we had last year that started in California, but the particulate matter and smoke from those fires reached pretty much the entire continental U.S. So we could see it here in Wisconsin. There were several days that you could see it, and it went as far to the East Coast as well. Also, you have microbials such as viruses, bacteria, spores, pollen, dust, and other allergens. The toxicity of those varies wildly, but there's still a matter of comfort and safety. We all know that pollens and mold, mildew, things like that, while they might not be lethal as some viruses and bacteria could be, they still can go a long way to causing discomfort. And then another thing that's in our air and a main focus or factor in controlling indoor air quality is VOC, and that stands for volatile organic compounds. And that's been something that is a major talking point or major item of discussion in regards to indoor air quality here in recent months. We'll talk here for a second about what the effects of poor indoor air quality are. They include both short-term and long-term effects. Short-term effects can make an occupant feel like they're sick or have allergies, things like dizziness, headache, fatigue, loss of productivity, and increased absenteeism due to these illnesses can result. And that's a key. The increased absenteeism is a key thing to remember. What I was saying a minute ago about occupant confidence and getting people to come back to these buildings once we're past COVID. Also, poor indoor air quality can exacerbate other medical conditions or allergies that people may have. Long-term effects of poor IAQ are still mostly unknown. There's been a number of studies done and a number of studies ongoing, but this focus on IAQ has been very recent, within recent months or years. So some of the long-term effects may include respiratory and heart disease. It may include things such as cancer. We don't know these things for sure yet, but that is something that more research is ongoing and will be released in the coming weeks, months, and years. At present, there's not a global standard for indoor air quality. There are several states, countries, and organizations that have published guidelines for VOCs and what they consider safe, and that's what's going to show on the next screen here. And I'm not going to go through these one by one, but what I will point out is that you can see a dramatic difference in what a number of these organizations and groups consider safe levels for VOC measurements. And I'll note that there's no outdoor air baseline measurement for VOC like there is for CO2. So when it comes to VOC measurement, there's no global standard and there's no outdoor air equivalent or outdoor air baseline measurement. So when it comes to VOCs, it's generally accepted that the lower they are, the better. But unlike CO2, there's no outdoor air baseline to compare it to. But you see on this slide that there are a number of organizations and states and other countries outside of the United States that have set some level of standards for both short-term and long-term exposure to VOCs. Looking at the causes of poor IAQ, we mentioned some of the sources. Some of the additional causes or sources of poor IAQ include combustion appliances that are internal to a building, furnaces, heaters, and other devices like that, tobacco smoke, building materials such as insulation, paint, flooring, upholstery, carpet. These things, when they're new especially, they can off-gas or emit VOCs that can cause irritation. You have chemicals that are used for cleaning, as well as personal care, cosmetics, hygiene. Essentially, anything that has a smell is likely to be emitting VOCs. Also, high temperature and humidity levels can be a cause of poor indoor air quality. And then also occupancy. The more people that you put into a space generally is going to track with more, or the more people you put into a space, the lower the indoor air quality. Some outdoor sources of poor IAQ are, in addition to what we had mentioned a few minutes ago, things like radon are naturally occurring and seeping from the ground, pesticides and other chemicals, and also outdoor air pollution, such as smog and smoke, etc. Generally speaking, poor IAQ or poor outside air is more common in urban areas, but it's not always the case, because if you go into more rural areas, you see there can be a lot of residential wood-fired stoves and boilers that can cause smoke and put particulate matter into the air. So it's not just a matter of urban versus rural. There are a number of rural areas that do have high particulate counts. The last thing we'll talk about as a cause of poor IAQ is inadequate ventilation. The air exchange rate is too low. And I mentioned demand control ventilation here because a lot of buildings operate under a demand ventilation. When occupancy rises, there will be automatically more air cycles. However, occupancy can be separate from indoor air quality because of these sources that we mentioned over the past few minutes. Poor outdoor air, cleaning chemicals and building materials can also be a cause of poor indoor air quality that's separate from just occupancy. So demand control ventilation definitely helps improve indoor air quality, but it's not the only solution to improving indoor air quality. So speaking of solutions, we'll talk for a minute about some things that are being promoted out there in the marketplace. Many of you may have seen these or be familiar with these. The first one that I'll mention is things like air cleaning, disinfection techniques, things like UV irradiation, ionization, and others. One of the benefits of these is that they can help reduce some of the microbials. They can kill viruses and bacteria. But one of the disadvantages of these is that it may not reduce CO2 and other gases or particulates that are in the space. So that's just targeted specifically towards things like microbials. We also have, as a solution, increased filtration. The benefits of that are they can reduce some of those particulate matters that are in the space, and as well as potentially some of those microbials. One of the disadvantages of that is your system might not be set up to handle a more strict filtration system, and it doesn't filter out or control occupancy. It's not going to filter CO2 and some other gases or chemicals that are in the space. It's more towards the particulate side. Increasing humidity can be a improvement, or I'm sorry, not just increase, but controlling humidity can also improve your indoor air quality. It can also reduce energy costs and reduce the spread of microbials. But the negative side of just improved humidity control is that some building materials might not be designed to handle higher or lower levels of humidity. And higher humidity could cause mold growth or degradation of those building materials. And it also is a result of, or it could result in increased equipment costs. And I put a question mark next to water treatment, because if you're adding humidity to the air, now your air is only as clean as your water is. So if your water has chemicals in it, or the water pipes have chemicals or particulates in it, that could be added into the air. So that's not a one-size-fits-all solution. And then the last solution that I'll mention is increased ventilation. And bringing in more outdoor air improves all aspects of indoor air quality. However, there are negatives with that as well. It's higher utility costs, and you have, in all likelihood, most systems aren't set up for 100% outdoor air. So there's going to be an additional added equipment costs. So in summary of the solutions, there's not a one-size-fits-all solution for improving indoor air quality. And we'll talk about that here when I conclude the presentation in a couple minutes. But now we'll mention some of the product solutions that ACI has that can help control and improve your indoor air quality. And I'll mention we've got products across multiple lines: temperature, humidity, pressure, current, gas, and air quality. And specifically on temperature and humidity, into all configurations. So room, duct, outdoor air, averaging, and all other configurations in pretty much any type of thermistor or RTD or analog output. I want to highlight also that we've got BACnet, MSTP, Modbus RTU temperature and humidity sensors. As we see more of a focus on indoor air quality, we see people want to increase the number of sensing points within a building, and you can't just snap your fingers and add more inputs to your controllers. So putting some of these sensors on your network is a way to reduce the equipment costs while increasing the number of sensing points and data that you're bringing into your system. I'll point out one thing about our pressure sensor that you see on the right-hand side of the screen. That's our DLP series. This device features selectable ranges and selectable outputs. And the selectable ranges are key because if you want to install it, install it in a building and then later down the road, you change the filtration. Well, that's going to change the differential pressure on either side of that filter if you put into it a medical grade filtration system. So that will cause you to have to change the dip switches on this device. So I mentioned that because this device then gives you and your customers options to change the settings on this without having to purchase additional equipment. And a number of our products do offer that type of selectability feature so that it can potentially reduce the need to purchase additional equipment down the road if you want to improve or change out some of these other systems to improve indoor air quality. We do have a full line of CO2 sensors for both duct, outdoor air, and wall mounts. We do have BACnet MSTP devices as well. And our newest sensors are the ones you see on the right-hand side of the screen, our VOC and particulate sensors. The VOC sensor measures a TVOC or a total VOC output. It does not measure a CO2 equivalent. So it's giving you a 0 to 1,000 parts per billion total VOC output. Our particulate matter sensor is measuring microns per cubic meter, and it's outputting that either as an analog or a Modbus signal from 0 to 500. That's microns per cubic meter. Both the VOC and the particulate sensors are available in the wall mount that you see in the middle of your screen with and without LCD display, and the duct mount version, which you see over on the right-hand side of the screen. And because these are Modbus, they're easy to get on your network, so you don't have to add additional controllers to bring another point into your system. So in summary, as we look to improving indoor air quality, we have to balance energy efficiency with improved indoor air quality. As I speak to you here in Wisconsin today, from Middleton, Wisconsin, it's about 4 degrees outside. So if we were to throw the outdoor air dampers open and bring in 100% outdoor air, it's going to send the utility costs through the roof. And our system can't handle 100% outdoor air when it's 4 degrees outside. So that's the balancing act in improving indoor air quality. As we mentioned before, increasing ventilation is the only proven method to improve indoor air quality across the board, both microbials like viruses and bacteria, as well as improving CO2 and reducing the particulate matter. Post-COVID, how do we ensure occupant safety, or like I mentioned, occupant comfort? We have to encourage people to come back into these buildings that are vacant now, our offices, our schools, our shopping centers, improving and documenting that we're controlling the IAQ in those spaces can go a long way to ensuring employees and customers and students are comfortable and confident to being back in these spaces, as well as preparing us for what could potentially be some regulatory requirements down the road. And lastly, as we mentioned, bringing in more outdoor air is the only way to improve all aspects of indoor air quality. There are other solutions to improve indoor air quality that are targeted to certain things, but there's not a one-size-fits-all solution to improve all aspects of IAQ other than bringing in more outdoor air and increasing the ventilation in your space. So that's what I had for you today. I want to thank you again for watching. If you have comments or questions, or if you're watching the archived version of this at a later date, please reach out to us with suggestions for future webinars and questions on this one. You can reach out to marketing@workaci.com, or you can email me directly at bk@workaci.com. So with that, I'm going to move on to the Q&A portion of the webinar, and I will answer some questions that were submitted ahead of time, as well as some that are coming in live as we speak. So the first question for today is, can your VOC sensor detect formaldehyde? The answer is yes. That device, or formaldehyde, is on the VOC spectrum that our sensor measures. However, we do see some specifications and requirements out there that require a specific formaldehyde sensor or a specific formaldehyde reading. And for those, we would recommend a separate specific formaldehyde sensor. But if it's a general formaldehyde as part of VOC, yes, our sensor will detect that. What is the ideal humidity and ideal temperature for indoor air quality? Yeah, a number of organizations have published guidelines. ASHRAE, the EPA, OSHA, and others all have guidelines on ideal temperature and humidity for IAQ. They're all very similar in nature, and all are approximately 30 to 60% relative humidity. You can go on the low ends in the winter and on the higher end in the summer, and between 68 and 77 degrees F for temperature to maximize indoor air quality. The specific numbers are different depending on who's making the recommendations, but they're all within that general range. Question, does VOC track with occupancy? Generally, yes, but not always. And I believe I mentioned this a few minutes ago in the webinar, how because VOC, a portion of VOC can be things like cleaning chemicals, building materials, paint, carpet, things like that, that are going to be present even without occupancy. It doesn't necessarily track VOC with occupancy. Generally speaking, yes, but not always. So a VOC sensor in and of itself isn't a great way to track occupancy in all scenarios. Another question, does ACI offer particle counters? No, our particulate matter sensor measures particle concentration, or essentially the number of particles per space, or the concentration per a space, which is a cubic meter. It doesn't offer a specific particle count. We see those more in clean room applications. There are devices that are out there that do offer a specific particle count, but that's a little outside the scope of what our particulate matter does. What's the accuracy of your VOC sensor? Good question. There's not a stated accuracy specification because the VOC sensor measures across a broad spectrum of gases and not any particular gas specifically. And so there's no way, or there's no metric or baseline to measure the accuracy of any one particular gas when using a VOC sensor. And that's commonplace, not just for our sensor, but for any VOC sensors that are available in the marketplace, you're not going to see an accuracy listed. For things like our CO2 and temperature and pressure and humidity sensors, yeah, we do have a stated accuracy specification for all of those devices that are measuring, one thing, one temperature, one humidity, or one pressure. So, but like I said, with VOC, because it's a broad spectrum, it's impossible to nail that down to any specifics. Are there sensors that can detect COVID-19 specifically or other viruses or bacteria generally? No, there's not any sensors that we have or that we're aware of in the marketplace that can detect specific viruses or bacteria. However, we've seen recently, there's been some studies that have been done recently that show a correlation between particulate matter levels and the severity of COVID-19 symptoms. So there's, a study just came out this week that highlighted that. So there is some correlation between the level of particulates in a space and the severity of COVID and other symptoms, but there's no way to specifically measure if COVID is present in a space with any type of particulate or similar sensor. So let's look at some questions here that have come in during the chat function. Can your sensors detect ion counts like an ion generator? No, unfortunately, the ions are essentially positive and negative charges of a specific element or essentially a specific element. And so our devices cannot detect the positive or negative charges within that specific element or that specific particle. That's what I meant to say. There are devices out there that do that, but that's outside the scope of any of our devices. Does your product line have a wireless hub or transmitter option? Some do. We do have wireless temperature and humidity sensors that are wireless in and of themselves. And we also have what we call wireless input devices that can take an analog signal from, say, a CO2 sensor or a VOC sensor, and then convert that signal to a wireless output and send that to our wireless receiver, which then can communicate to your control system or your BMS system. So yes, for wireless devices in and of themselves, that's limited to just temp and humidity, but we do have those what we call input devices that can accept an input and transmit that to a wireless receiver. Do ACI sensors come with NIST certification for validated environments? Most of our sensors, yes. Pretty much all of our temperature, humidity, and pressure sensors are available with NIST certificates upon request. Gas sensors, specifically CO2, toxic and combustible gas sensors, we can, and as well as our VOC and particulate sensors, those are not available with an NIST certificate simply because there's not an NIST standard for measuring those gases. So what we provide or can provide with those is what we call a certificate of conformance, which states that the product was tested and calibrated at the factory and built to our internal quality standards. And that's commonplace for those sensors for which there is not a NIST traceable standard to measure. Question, why Modbus RTU and not BACnet MSTP? I assume you mean that for the VOC and particulate sensors, because we do have BACnet MSTP available for temperature and humidity and a couple of our CO2 sensors, but it's not yet available for the VOC and particulate sensors. And that's just due to the current room that we have on the board. We're hoping that can be done in a future generation of the product, just simply not available yet at this time. What size particulates does your particulate matter sensor read? PM 2.5 or 10? The device that I mentioned and show the photos of, that is a PM 2.5 device, which it's our understanding that those smaller particles are the ones that most influence or it can affect occupant health. And we are exploring and looking at PM10 devices. Those are the larger particles like dust and things that you may be able to, that would have may be able to see with slightly with naked eye. We are looking for more feedback on that. If you see specs or requirements for particulate matter 10 or PM10 measurement, please let us know. We're looking to potentially add those devices into our catalog. From what we've seen so far, it looks like PM 2.5 is what's more generally required or specified, but we very much would like some feedback on PM10 as well. There are a couple of questions about the California bill that were passed. Off the top of my head, I don't know the name and number, but if you want to reach out to me by email, I do have that info on file and I can send that to you. We have seen that. It was passed, I believe, last September and went into effect here early in 2021. One more question just came in. Do you have any recommendations for how to mitigate mold growth potential when adding humidity? Off the top of my head, I don't have any specific recommendations for mitigating mold growth. That's something that we can discuss offline, and I can get some more specific details for you on that. But yeah, why don't, if you could email me, bk@workaci.com, I can get some more specific requirements and recommendations for you. So with that concludes the webinar and Q&A for today. Please reach out if you've got questions or comments or feedback at any time, either at marketing@workaci.com or directly to me at bk@workaci.com. Thanks again for joining. Look forward to talking with you again soon. Have a great day.